Welcome to section 1.5, infinite limits and vertical asymptotes. Your goal is to be able to determine infinite limits from the left and the right and find vertical asymptotes of a graph of a function. Guess what? These two go hand in hand. If you can do one, you have to be able to do the other one. Main things I want you to think of with this, the infinite limits, is we are talking about as x approaches a number. F of x, the function, is approaching positive or negative infinity. It's not going to be both, but it's going to be one of those. Therefore, what you're thinking of is the limit of the function is positive or negative infinity. Really, we say the limit of the function does not exist. That's really the case. But we can give a direction and say it's going really high or it's going really low. The function is increasing or decreasing without bound. Think of it like that. The function increases or decreases without bound. Okay, as x approaches a number. As x approaches a number, the function approaches positive or negative infinity. Think of it graphically. Now this goes hand in hand with a vertical asymptote. So I want you to see it as a vertical asymptote. Okay, so just a quick picture here. I'm going to draw a vertical asymptote. Just let's say here at x equals -2, that's going to be our vertical asymptote, the equation of the line, x equals -2, and maybe there's a horizontal asymptote, maybe not, it doesn't matter. What I want you to visualize is the function is increasing without bound, decreasing without bound. Let's call this guy here f of x. And let's talk about how on the left, see this guy is decreasing without bounds, so we're going to say the limit as x is approaching -2 on the left, the function is decreasing without bound. The limit is negative infinity. Versus on the right, as we approach -2 on the right, so I say the limit as x approaches -2 on the right, the function is approaching positive infinity. Now, if we were to write, what is this limit as x approaches -2? Well, we can't say positive or negative infinity because one is positive, one is negative, so we just have to say does not exist. Now, if we could be more specific, we would and say positive or negative infinity, but we can't in this instant. Looking at it analytically, you must be able to do this without a graph. So think of it like this. You get 0 in the denominator, and you can't factor it out. Remember, when you can factor it out, it's a whole. So you're thinking of it as there being no common factor. Then it's a vertical asymptote. So for example, that function in that graph could have been 1 over x plus 2. So if we were to say, let's find the limit as x approaches -2 of 1 over x plus 2, well, I see that the denominator, x plus 2, will equal 0 when x equals -2. Therefore, I know there has to be a vertical asymptote that is x equals -2, and because it can't factor out from the top, it's not a whole, it's a vertical asymptote. And I know that that limit, therefore, does not exist. Now, whether it's positive or negative infinity, that's what we need the numerical part for. So numerically, what we're going to do is say, well, what if we look at -2, but really, really, really close to it, like -1.9 on the right? If we look at an x value really close to -2, but on the right, like -1.9, would this be positive, meaning way up here, or would this be negative, meaning way down here? Well, we know what the graph looks like, so let's look at it if we literally plugged in that number. So I'm going to do my work down here so I can summarize it for you up there. 1 over x plus 2. I'm going to plug in for x something really close to -2, like -1.9. On the top, I get a positive number, 1. On the bottom, I get a positive number, and a positive divided by a positive is a positive. Therefore, I can conclude that the limit as x approaches -2, but coming from the right, so a little bit more positive than -2, of 1 over x plus 2 equals positive infinity. I'm concluding that from looking at the numerical approach. That's a faster way than looking at a table of values. So please give yourself a summary that you're going to substitute, when you're looking at it numerically, substitute a decimal number really close to the x value of the vertical asymptote and observe positive or negative. Let's take a look at some examples. Write the equation of the vertical asymptote if it's possible. There's not always going to be one in any function. In every function, I should say. Then find the limit as x approaches 5 from the left, 5 from the right, and 5 analytically and numerically. Well, vertical asymptotes go hand in hand with infinite limits. So we're thinking ahead that probably these are positive, negative infinity, something like that. Let's start with taking our denominator, setting it equal to 0. So x squared minus 25 will equal 0. If I factor that, difference of squares, when x equals 5 or x equals -5. But if we factor this and rewrite our function, f of x equals x plus 5 over x minus 5 times x plus 5, one of these factors out. The x plus 5 factors out. So in fact, the x plus 5 that gave us -5, that's a whole. That's not a vertical asymptote. This one that stayed, x minus 5, gave us x equals 5. That's our vertical asymptote. So to answer the first part of our question, the vertical asymptote is x equals 5. So we did that first part. Now we know if there's going to be a vertical asymptote, there has to be a limit that is infinite, an infinite limit. So we want to think, to answer the second part, find the limits as x approaches 5 from the left for this function, that we're either going to get infinity or negative infinity. We know that. So let's plug in a value very close to 5, but on the left. Let's look at perhaps 4.9, very close to 5, but on the left. So 4.9, oh, we have to plug it in where the x is, and the x is in the bottom. So I'm thinking, and let's use the simplified version, 1 over x minus 5. Now I'm not saying equals, I'm just doing some scratch work down here. So 4.9 is close to 5. 4.9, let's fix that little, make it a little bit better. 1 over 4.9, I'm plugging in for the x, minus 5. On top, I see positive. On the bottom, I get negative. And a positive divided by a negative makes a negative. Therefore, I know that that limit will have to be negative infinity. I know, remember that I know it's either negative infinity or positive infinity because there's a vertical asymptote. So there is one of my results. And I don't usually circle it, but there's a lot of work going on here. I don't want you to get lost. Second thing I want to look for is, it says limit as x approaches 5 from the right. So as x approaches 5 from the right for this function, now I want to pick something really close to 5 but on the right, say 5.1. So 5.1 plugged in gives me a positive on top, positive on the bottom, and a positive divided by a positive equals a positive. So go up here and I know it is positive infinity. Now again, like we said before, I cannot give a negative infinity or a positive infinity because they are different. So finally, the limit as x approaches 5 of f of x does not exist. That's that last answer. Please graph it in the calculator and see it a visual. Number 2, I don't see a denominator, but I see that it's tangent, and we know that tangent can be written as sine x over cosine x, and there is a denominator. Now, if you're very familiar with your tangent function, you know where the vertical asymptotes are. If you're not, hopefully you at least know that the denominator is cosine x. Let's set the denominator equal to 0, and that's going to happen at a lot of places. The first place it happens is at pi over 2. I don't have to keep going because what my goal is to find the limit, and I see that I'm looking for the limit as x approaches pi over 2. That's where there is a vertical asymptote. So I know that this limit is either going to be plus or minus infinity. Let's figure out which. Now we're coming from the left. So what I like to do is think of a number from the left. Now, perhaps you give yourself a little visual. Here's pi over 2, something from the left, something from the right. We don't want to pick 0 because on our unit circle, that's a whole section away. Let's pick something that's just in the first quadrant, maybe like pi over 3. Something to the right would be something like 2 pi over 3. You don't want to go too far away when we're thinking of the unit circle. You really want to be close when you're thinking of the numerical approach. So if you maybe take this into your unit circle, here's pi over 2 up here. Here is pi over 3. Now we talked about, remember, coming from the left. This is from the left. Pi over 3 is on the left, so here we are, so pi over 3. Now if it helps you to remember that all students take classes, that, remember, is that all of them are positive here. Only sine is positive here, only tangent's positive here, cosine is positive here. However you remember it is fine, but the point is I'm getting positive numbers when I'm at pi over 3. So I know that the answer to my limit question, as x approaches pi over 2 from the left for tangent of x, it's positive infinity. As I look at coming to pi over 2 from the right, well, take a look at, back to our picture here, the right, 2 pi over 3. 2 pi over 3 is in this section, and 2 pi over 3 is in the sine quadrant. So only sine is positive, which means that tangent will not be positive. So tangent will be negative there. So here the limit as x approaches pi over 2 from the right will be negative infinity.